Hi dear students, in the last class we have discussed about the Hooke's law. Scientist Robert Hooke was suggesting or explaining the relation between the stress and the strain for a particular object. That was represented or explained in the Hooke's law. That means stress will be proportional to strain for an elastic deformation. And we have seen the proportionality constant in that case is represented by K, and it is known as the modulus of elasticity. As well, in the last class, as we concluded, we have seen the modulus of elasticities are three types: Young's modulus, shear modulus, and a bulk modulus. Now in this section we will discuss a stress strain curve for a particular body. If we are increasing the load or if we are increasing the stress, what would be the strain values? Or how does the stress and the strain values are related? And on the addition of load, what would be the major observations occurred? These things can be explained very well with the help of a stress strain curve. So from the stress strain curve of a particular object, we can find out its elastic behavior. Or else we can say how does it reacts to the adding load. So the stress it is taken in the y-axis and strain it is considered in the x-axis. So you can see from origin O to A, the curve it is a straight line. The curve is a straight line. So that means from O to A, the object it is under the elastic behavior. That means the stress it is directly proportional to strain. Stress is directly proportional to strain. That means here in this region, that particular body or the object is following the Hooke's law or obeying the Hooke's law. From A to B, if you are observing, you can see the stress value. Even for a stress, small change in the stress, there will be a sudden increase in the strain value. Means if we are means here the stress and strain is not linear. This region is not following or obeying the Hooke's law, and even increasing the stress by a small quantity or small value, the strain increase in the strain is very large. Even though if you are removing the load or if you are removing the stress, the body will regain its original shape or original dimension. Where the point B, it is known as the yield point. So that means till point B, the plastic behavior will be there. Sorry, the elastic behavior will be there. That means the body can regain its original dimension or the original shape as we are decreasing or as we are removing the load. And the stress value corresponding to the B, point B, it is known as yield strength. And from origin O to B, it is called elastic region, where from O to A, the body it is following the Hooke's law. From A to B, it is not under the Hooke's law consideration, but still, as we are removing the load, the body can regain its original shape and position, dimension. Hence, we can say from O to B, the body is under the elastic behavior, or it is known as the elastic region. Now consider B to D. Where a point C it is considered in between B to D, a point C it is there. From that point C, the body cannot regain its original shape and dimension even if you are removing the load. So that means from point C onwards, as you are increasing the stress or as you are increasing the load, the body became in the plastic region, and it is known as the body material is said to have, or material is said to be the permanent set. And this deformation it is known as the plastic deformation. And where a point D, you can see the point D where the maximum stress that you can apply. And the point D on the graph, that one it is known as the tensile strength. Point B, it was yield strength. The stress value related to point B was known as the yield strength, and the stress value which is related to the point D, it is known as the tensile strength. Now from point D, after the point D, you are decreasing the stress. That means you are decreasing the, or you are removing the load. Then also you can see the strain, it is increasing. That is the additional strain, it is coming. So that particular point, it is fixed by that point D can be fixed by in such a way, the point where thereafter decreasing the stress causes increasing or additional strain. That point D, that is from that point, it is known as the, or the stress value related to that point, it is known as the tensile strength. So the stress value will decreases even if you are increasing the strain. And the last point E, that is known as the fracture point. So the maximum stress value, that is D, tensile strength. Further, if you are increasing the strain value, if you are adding the strain value, then you can see the stress in the material is getting decreases. And a particular point E, the material will break, the body breaks. At that particular point, it is known as the fracture point. So on the basis of this stress strain behavior, we can measure a particular body's elastic behavior as well the plastic behavior, and as well we can find out the fracture point of a particular body. In such a way we can measure the maximum load that can be applied a particular body. Suppose in the construction of a bridge and all those things, buildings, and in such cases we can measure the stress strain behavior, the materials that you are using over there. You are supposed to measure the stress strain behavior, and as well we have to find out the tensile strength value, and as well the fracture point, the maximum load that can be carried by that particular body. All those things that you have to measure. So this stress strain graph is having such a great application in our day-to-day life. And in textbook, the stress strain behavior of the aorta, the blood vessel from the heart, it is given in the textbook. You can see that here the stress strain behavior, the proportionality, it is not there. Actually, a parabolic graph we are having. a curve it is there. So the such materials even a small value increase in stress causes a large increase in the strain. Such materials are known as the elastomers. So the term you should remember, elastomers. Elastomers, even a small increase in the stress causes a large increase in the strain value. And they usually they won't follow the Hooke's law. Here the representation is given. Where the material is not following the Hooke's law, the majority region. Now let us come to the Young's modulus. Young's modulus in the case of the tensile strength, it means if you are applying the normal stress, a compressive or a stretching force, if you are applying, then the stress by strain relation, the stress by strain ratio gives you the Young's modulus. That means the longitudinal stress divided by the longitudinal strain. That is the Young's modulus. The longitudinal stress is obtained by the time, or it is represented by the symbol sigma, and the longitudinal strain, it is represented by the symbol epsilon. So as you know, the longitudinal strain is actually the force, that is the restoring force per area, that is F by A. And the longitudinal strain, it is actually the variation in the length divided by the original length. That is the elongation occurred divided by its original length. So comparing or that is F by A divided by delta L by L. So we can write this one, that is the Young's modulus as F into L divided by delta L into A. Delta L into A it is there. That is Y is equal to F L divided by delta L A. This is the Young's modulus. As we know, the strain value is not having any units and as well the dimension. So the Young's modulus will be having the unit of the stress, that is the force per area, that is Newton per meter square. And it is known as the Pascal. Here it is given that metals are having the higher Young's modulus value. So that's why for changing the shape and as well length of a metal, we have to apply more force, or we have to apply more stress. So now the shear modulus and as well the bulk modulus we will discuss in the coming classes. And one problem it is given, let's go through that one. A structural steel rod has a radius 10 millimeter and a length 1 meter. A 100 kilonewton force stretches it along its length. So longitudinal stress it is there. Calculate the stress. So for finding out the stress value, the force applied, that is 100 kilonewton divided by the area. So here the radius is given in millimeter. So first of all you have to convert that into meter, and using the pi r square value you can find out the area of the region, and then substituting those values, that is F by A, you can find out the stress. So the stress it is given here. Then it is given that to find out the L, delta L, the elongation, how much elongation is happened. And for that purpose, the Young's modulus value it is given for the steel as 2.0 into 10 raised to 11 Newton meter raised to minus 2. So using that Young's modulus, actually Young's modulus value will be a constant for a particular material. So material to material the value will vary, but if you are considering in the various objects which are made from the same material, they will be having the same modulus value. So using the modulus, Young's modulus equation, that is y is equal to F L divided by A delta L, you can find out the delta L value as delta L is equal to F L divided by AY. So substituting the available data in this equation, you can find out the delta L value, and you can find out the strain. Also you have to find out the strain. So that is delta L by L, that is ratio delta L by L. And if you are multiplying that with the 100, that means you can find out the percentage strain by multiplying that with the 100. Okay. So these are the major things. So shear stress and as well the shear modulus and as well the bulk modulus we will discuss in the coming sections. So in your textbook, some more examples are there. Go through the examples, then it will be very easy to understand the concept. So two or three equations are there. So on the basis of the equation, you have to find out the comparing, means changing the values and substituting the values. You have to find out the various values in the questions. The same equations only you have to use there. And as well the stress strain graph, the terms in the stress strain graph, that also you have to study well. The yield strength, the tensile strength, then the plastic region, then as well the fracture points, and all those things, the new terms that you have seen today. They should be familiar with those terms also. So read the textbook. Thank you.